Hello. In this question, we are investigating Beer's law and spectroscopy. The lessons we learn here about graphing, though, can be used for any kind of graphing. In this question, a weak acid called HIN, which is an indicator, absorbs a greenish-yellow light at 570 nanometers. The absorbance of that light increases as the concentration of the indicator increases, according to Beer's law, which also incorporates the distance a light travels through the solution, called B, and the molar absorptivity of the species in the solution, which is unique for every different solution at every specific wavelength. Mathematically, we see this as A equals epsilon B concentration of indicator. Beer's law is a linear equation where the B, the intercept, is equal to 0. If you collect the following absorbance data over a variety of concentrations for HIN, we have several questions to think about. First, we want to plot this data in this range and see if it obeys Beer's law. That means, does it produce a straight line when we plot it? Secondly, we want to determine the molar absorptivity, the epsilon, for this particular species, HIN, using the plot of our data, given that we have a path length, or B, that's equal to 1 centimeter. And third, we want to determine the concentration of an indicator solution that we've measured the absorbance for of 0.325 absorbance units, but we want to know what the concentration is. So first, we would go probably to a graphing program like Excel or Kaleidograph to make this plot. We enter in the values of absorbance on our Y, concentration on our X. And then we can ask the program to fit the line using a linear least squares analysis to give us an equation for the line that tells us how the line fits and what the relationship is between what we've put on the y-axis and what we put on the x-axis. In this case, absorbance and concentration. So it does look very linear, so we do obey Beer's law in this concentration range, and we find that the y is equal to 7562.7 reciprocal molarity is our unit for our slope times x. So in our second question, the question is, what is the molar absorptivity, or what is the epsilon? So we can use our equation for Beer's law, absorbance equal epsilon B times the concentration of HIN for this system. For the graph we just made, our absorbance is equal to 7,562.7 reciprocal molarity times the concentration of indicator. So epsilon times B is equal to our slope, or this value right here, 7,562.7. Since our B was 1 centimeter, our epsilon can be found by just simply dividing the slope by 1 centimeter to get the epsilon value, which is 7,562.7 reciprocal molar reciprocal centimeters. Often, this is done in a laboratory where we're trying to find unknown values. We set up a Beer's law plot and then measure unknown values. So the third part of our question is, if we have this relationship that we've determined between absorbance and concentration of our indicator, and we measure the concentration we actually measure the absorbance of a concentration for which, and if we have the concentration of a solution we want to know, an unknown solution, but we can measure the absorbance, we can relate that back to the concentration. So, since absorbance is equal to 7,562.7 molarity times concentration of indicator, we can use that equation to find the concentration, in this case 2.3 times 10 to the negative fifth molar, of our unknown solution of which we've measured the absorbance. For more on graphing, please see the math modules below and try the problems in the You Try It section.